question, is that it's asking what is the percent yield. But let's run you through it. So you begin with 11.34 grams of carbon monoxide, which is one of our reactants, and 6.02 grams of oxygen, which is my other reactant. And then I have 11.4 grams of CO2, which is my product. And this is a limiting reactant problem. We know that because we have grams of two different reactants, we can turn those into moles. And so this problem starts exactly the same as the last one, but it has one more step at the end. So let's find our limiting reactant and how much product we can make. We have 11.34 grams of carbon monoxide. Same setup, carbon monoxide, 12.01 for carbon, so that's going to be 28.01 grams per mole. Then it's 2 to 2. And the molar mass of carbon dioxide, which we may remember from our combustion analysis days, though we may try to forget it, is 44.01 grams per mole. 11.34 divided by 28.01 times 2 divided by 2, so we can skip that step, times 44.01. I get 17.8 grams of carbon dioxide. Rinse and repeat, as they say. So 6.02 grams oxygen. I know that there are 32.00 grams of oxygen per 1 mole. I know now, using the balanced reaction, that there's 1 mole of oxygen for every 2 moles of carbon dioxide. And the last step in these, the way I do it, is always the same. Now let's multiply this out. 6.02 divided by 32 times 2 times 44.01. I get 16.6 grams of carbon dioxide. And if this were any of the previous problems we've been working on, we would be done. We would say the smaller amount is the amount that we can actually make. Done. But we're not. This now says if 11.4 grams of carbon dioxide are produced, what is the percent yield? The percent yield formula, and applying it for carbon dioxide, says the actual yield divided by our calculated or theoretical yield, where the word yield just means how much you actually calculate, or grams, calculated grams in this case, times 100%, because percents always have times 100% at the end. Now you do have to use your amount for your limiting reactant as your calculated yield. So plugging this in, the actual yield will always be in the problem statement. And in practice, the actual yield is something that you would do in the lab. Since there is no lab part to this, it will have to be in the problem statement. And so we end up with 11.4 grams of carbon dioxide divided by our calculated yield, 16.6 grams carbon dioxide, times 100% will be our percent yield. So 11.4 divided by 16.6 times 100. I get 68.7% yield CO2 as my answer for this. Any questions about this problem?